Let's look at some completing the square. So completing the square is an algebraic technique generally for quadratic trinomial expressions. So here's an example for you. If I have x squared plus 10x plus 30 and I complete the square in it, I rewrite it as x plus 5 squared plus 5. So completing the square is writing a quadratic expression as a perfect square plus or minus some remainder. So this is our perfect square plus some remainder. So the idea is we first have to understand what a perfect square is, and once we understand what a perfect square is, then we can figure out how to calculate the remainder. So let's look at some perfect squares. So let's say, for example, I take something simple like x plus 3 and I want to square it. So we already know that that's x plus 3 times x plus 3. In other words, x squared plus 3x plus 3x plus 9. So that's x squared plus 6x plus 9. This thing right here, x squared plus 6x plus 9, that is a perfect square. So it's a perfect square because it can be written as x plus 3 squared. Let's have a look at one more example here. Let's say I take something like x minus 5 and I want to square that. So we know that that's x minus 5 by x minus 5. So that would be x squared minus 5x plus 25. So in other words, x squared minus 10x plus 25. X squared minus 10x plus 25. That is another perfect square because it can be written as x minus 5 squared. So that is the idea of a perfect square. And as you practice these, you will get more and more familiar with them. So we need to understand how to go the other way. So let's say, for example, I start off with x squared plus 6x plus 9. And I have to represent this as the perfect square. So we already know from looking over left here, it's x plus 3 squared. We know that it's x plus 3 squared. And how do we recognize that? Well, initially you could say we have two ways. You can say that we know that it was 3 by 3 that gave us the 9. So because 9 is 3 squared, that must be a 3. Another way people look at it is the 3x plus the 3x gave me 6x. So because 6 is 3 plus 3, well, that must be a 3. So you have two different ways of figuring out the perfect square. But my advice to you is we want to stick with this option here, looking at the middle value. So the reason we want to do that is if I had two perfect squares, let's say I had x squared minus 10x plus 25 versus x squared plus 10x plus 25. So these are two different expressions, but they both have a plus 25. So we can't tell the difference by looking at the 25, but we can tell the difference by looking at the second coefficient here, the tens. So the one on the left we must know is x minus 5 squared, and the one on the right we must know is x plus 5 squared because of the minus here and the plus there. So the way I like to think about it, when I'm trying to calculate a perfect square, the way I like to think about it is halving the middle values. So another example, if I had like x squared minus 12x plus 36, I look at the middle value and say, well, half of minus 12 is minus 6. So this must have been x minus 6 to be squared. And we can see that when you square minus 6, you will get plus 36. That is perfect squares. Now let's see how we can use that for the completing the square technique. So I'll do an example here for you. I'm going to go through this one here. Question 2, part A. Complete the square on the expression x squared plus 10x plus 30. So we've got our x squared plus 10x plus 30. And remember, to complete the square, we have a perfect square plus or minus some remainder. So the first thing we got to do is analyze what's the associated perfect square. And remember, that's about halving the middle value. So our associated perfect square is going to be x plus 5 to be squared. So working through that, you got your x plus 5 and your x plus 5. In other words, x squared plus 5x plus 5x plus 25. So the associated perfect square is x squared plus 10x plus 25. Now remember, we said to complete the square, you rewrite the expression as the perfect square plus or minus the remainder. So the perfect square is x squared plus 10x plus 25. Now we have to add in our remainder, and our remainder in this case is going to be 5. Because remember, we're not changing this expression, right? This expression has to remain the same. So if this is a 30, well, these numbers have to be 30. So we got our 25 from here, but we have our 25 plus our 5 adds up to the 30. The way some people like to look at that is they like to always say that it's the first number, 30, take away the number from the perfect square, take away 25, that gives you the remainder of 5. That's another way to look at it. Back to the expression then, we have the x squared plus the 10x plus the 25. We know that that is x plus 5 to be squared. We already figured that out, remember, over here. And then we have our remainder, our plus 5. So x plus 5 squared plus 5, that is the same as our x squared plus 10x plus 30. It's just a different way of rewriting it, and it's writing it in the completing the square format. Let's have a look at one more example here. I will go through this question here, part C. So x squared minus 8x plus 13. So once again, the first step is to figure out the associated perfect square. And we do that by halving the x coefficient. So half of minus 8 is minus 4. So I'm thinking x minus 4 to be squared. And I go to my rough work and I'll just work that out again and take my time. So I've got my x squared minus 4x plus 16. So I've got my x squared minus my 8x plus 16. So this is the associated perfect square. So I'm going to rewrite the expression on the left here as x squared minus 8x plus 16. And what about the remainder? Well, the remainder will just simply be 13 take 16. That is minus 3. So minus 3 is my remainder. And as you can see here, you know, the x squared is the same as the x squared, the minus 8x is the same as the minus 8x, and 13 is the same thing as 16 minus 3. So then again, I know that the first three terms here, x squared minus 8x plus 16, that is x minus 4 to be squared, and then I have my remainder of minus 3. So there we go. X squared minus 8x plus 13 can be rewritten as x minus 4 squared minus 3. It is important to understand that the method I've just shown you is for situations where you just have a 1x squared. So both of the examples I showed you, you just had a 1x squared. What we need to do now is look at an example where you have something other than a 1. So I'm going to look at this part here, part J, 2x squared plus 10x plus 11. So if you have, you know, a number rather than 1 in front of the x squared, the best thing to do is just factorize that out, and then everything else remains the same. So I'm going to factorize out the 2, and then in the bracket, I'm going to have x squared plus 5x plus 11 over 2. So I factorized out the 2, and now all I have to do is just complete the square on what you have in the bracket, and the method for this is the exact same. The numbers may not be as nice, but the method is the exact same. So let's get started on it. Remember the first technique? What is the perfect square? You half the middle value. So half of 5 is 5 over 2. So I'm thinking my perfect square is x plus 5 over 2 squared. So that's x plus 5 over 2 times x plus 5 over 2. So you're going to have x squared plus 5 over 2x plus 5 over 2x plus 25 over 4. In other words, x squared plus 5x plus 25 over 4. So x squared plus 5x plus 25 over 4, that is the associated perfect square. So back to the left here, I have 2 times x squared plus 5x plus 25 over 4. Now what about the remainder? Well, to get the remainder, remember it's as simple as saying 11 over 2 take 25 over 4 is going to be minus 3 over 4. So minus 3 over 4 is my remainder. Minus 3 over 4. So then I just continue on here. I rewrite this as 2 times. I know that the x squared plus 5x plus 25 over 4, I know that that is x plus 5 over 2 to be squared, and then I have my minus 3 over 4. The last thing we can do is we can multiply the 2 back into the bracket. Now, when we multiply the 2 by x plus 5 over 2 squared, it simply remains as 2 times x plus 5 over 2 squared minus then 2 times 3/4 is 3 over 2. And that is it completed. So 2x squared plus 10x plus 11, rewriting it by completing the square as 2 times x plus 5 over 2 squared minus 3 over 2. So that is completing the square. The best thing for you guys to do now is practice some of these questions, check your solutions. And for access to questions, solutions, graded quizzes and more, visit www.livingmaths.com.